Hello, hi everyone. Welcome to this brand new Learn Live episode where we are going to build a Copilot application using the Retrieval Augmented Generation pattern in the Azure AI platform. I'm Carlotta Castelluccio. I'm a cloud advocate in Microsoft. I'm focused on artificial intelligence technologies. And I'm here. I'm happy to be here today with to share this virtual stage with Graham Malcolm. How are you doing, Graham? Would you mind to briefly introduce yourself?
Absolutely. I'm doing well, Carlotta. Lovely to see you. Yep, I'm Graham from sunny Seattle this morning. It's a bright sunny day this morning, so that's great. So I'm joining you from the west coast of the United States and looking forward to digging into building a RAG-based Copilot with Azure AI Studio.
Awesome. And feel free to share where are you joining from. I'm personally joining from Italy. I'm in the south of Italy right now. So yeah, feel free to share where are you joining from. I know we have a global audience and that's really amazing. So if you are joining this Learn Live series for the first time, I just wanted to, provide you some more context about how this episode plays itself within the series. So this is part of the Microsoft Learn AI Skills Challenge learning experience, where we basically are combining a self-paced gamified learning experience with the Cloud Skills Challenge with a guided learning experience through these trainings in the Learn Live show format. If you're not familiar with what a Cloud Skills Challenge is, basically it's a gamified experience where you have a collection of Microsoft Learn content where you can go through this collection of resources on your own. We have 4 different tracks. So make sure to check what are the topics that you are most interested in, and go through the track you prefer. You can also have the chance to win a free certification voucher. So make sure you check the whole learning resources we have prepared for you. So Graham, do you want to anything to add here about the Microsoft Learn Challenge?
No, just to really encourage you to take a look at that. The content on Microsoft Learn that is used in the challenge is something that my team builds over here in the US and Microsoft, and we really are excited to be releasing a whole bunch of new modules every day as the AI journey continues. So please engage in that AI skills challenge and consume all of this great content that's being produced up there.
Perfect. Yeah, and all feedback are appreciated. So feel free to share also your feedback as you go through this material. In terms of the Learn Live series, this is the 8th episode of a series of 9 episodes. So tomorrow we'll be having the grand final, where Ivorberry and Raffaele Rialdi will be covering in details how to build an Azure AI Search solution for the Retrieval Augmented Generation framework. And we are going to also briefly touch these today, but tomorrow will be, a deep dive into the search solution. And before, starting here, I want to just say hi to our moderator. Hi, Amit. Thanks for your support. He will be supporting you throughout the whole live streaming. So if you have any questions, if you have any comments, feedback, he will be there for you, and for us to support us. So thanks, Hamid. And then talking about the content on Microsoft Learn, this session is based on a Microsoft Learn module, which has, as Graham just said, has been released pretty recently, which is called Build a RAG-based Copilot solution with your own data using Azure AI Studio. So you can use these learning resources to follow along with this Learn Live streaming, or you can maybe go through it at your own pace after you watch this episode. You have here the aka.ms link that will be shared also in the chat, and you have a handy QR code if you prefer, just to scan the QR code here. And this live streaming is live and interactive. Again, we have Amit in the chat to help you answer a few questions. We are happy to, pause from time to time to answer your questions, if any. So feel free to comment and ask questions in the chat. And I'm seeing already a few comments coming, so thanks for doing so. Coming to the learning objective for this session today, we have, I would say, 3 main objectives. So the first one is really to explore the benefits of grounding a large language model with the Retrieval Augmented Generation pattern. And don't worry if you don't know what grounding meaning or what Retrieval Augmented Generation means, because we are really going to demystify all those concepts. And then we are going to see how to index data with Azure AI Search to make it searchable for language model. And after that, Graham will be, do some hands-on demos and is going to really show us how to build a Copilot using the RAG framework on specific data, on custom data, using Azure AI Studio and prompt flow. So I would like to start this presentation with a question, because I know that if you are familiar with the Microsoft ecosystem, you might have already heard the term Copilot several times. So I'm curious if you all have an understanding of what a Copilot is. So what's your understanding, your definition of Copilot? And I don't know, Graham, would you like to provide me with maybe your definition in a few words of what a Copilot is?
Sure. Well, many years ago, back when I lived in Scotland, I learned to fly. There was a local flying school when I went, and I learned to fly a little Cessna airplane. And one thing about learning to fly in Scotland is you learn to fly in pretty adverse weather conditions, so pretty windy conditions. And what was great is, as you're learning, effectively you sit in the pilot's seat, you are the pilot of the aircraft, but your instructor is your co-pilot. Your instructor is sitting next to you, and they are there to help you with the things that you're perhaps going to struggle with. They are there on hand always to be a knowledgeable source of information, or to make sure that you are getting everything done that you need to get done as effectively as you can. And that, to me, is what a co-pilot is in the computer world. We've got this idea of something that sits beside you in context as you're doing some work and draws upon the information that it has from being trained with a large language model, so that it can communicate with you and help you get your day-to-day work done more effectively.
Awesome. Thanks, Graham, for this fascinating definition. I've seen some other answers coming from the chat. I've seen Tyndall saying black box. So today we are hopefully going to demystify a bit this black's magic box. And I will give you, a more practical definition of what a Copilot is in the Azure ecosystem. So with the term Copilot, basically we refer to a virtual assistant. So something like a chatbot you might be already familiar with, a virtual assistant solution hosted in the cloud using a large language model, so based on a large language model which is used as chat engine, and which is fed with business data, so custom data and custom prompts, and eventually also integrated with third-party services and plugins. So Copilots provide users with an intuitive chat-based application to receive assistance on a certain domain or business scenarios, and as Graham said, to be an assistant, be the assistant of the pilot, who is you, of course, the developer. Now, when it comes to Copilots, Microsoft is not just a service provider. Of course, you can use built-in Copilots, and maybe you already played with some of those, like Copilot for Microsoft 365, Copilot in Bing, or GitHub Copilot. And hey, I'm also curious about which Copilot did you use already, so feel free to share this in the chat. But we can also choose to build our own Copilot by leveraging the same infrastructure, which is Azure AI, on which Microsoft Copilots are based. And this image in this slide shows what we call the Copilot stack. So behind every Copilot, there's a layer of AI orchestration toolchain, the pink one you see here. And this basically is an orchestration toolchain used to extend, test, and deploy your AI application. And then at the bottom, we have the foundation of everything, which is, of course, AI. So basically, we select the most suitable model, pre-trained large language model for our application needs, from the Azure OpenAI service, for example, or the model catalog. And then this sometimes might not be enough, when designing a Copilot for a specific use case. So in some cases, you want to ensure your language model is grounded and use factual information that is relevant to your user needs. And this is possible by augmenting the pre-trained large language model with your data, as we are going to do today, to enable more accurate responses. And that's why you see here this layer, this sub-layer, which is called your data, together with the foundation models. As we delve into building a Copilot application on custom data, it's important also to understand the whole development lifecycle of a Copilot application. If you have followed, previous sessions of this series, you might be already familiar with this slide. But I really wanted to start from here because I would say that the intelligent application has the development of intelligent application has witnessed a big shift, a big change with the advent of generative AI. So we shift from classical machine learning, where we trained our models on specific statistical algorithm to predict predefined outcomes, to leverage pre-trained large language models to predict outcomes which are non-deterministic, because for the same input we can get different outputs. So this really has impact on the whole development life cycle, and this also led to what we call today large language model operations, which is basically machine learning operations applied to large language models. And this new development life cycle consists of 4 stages. We have the initialization phase, where we define the business use case and we design the solution. Then we have the experimentation phase, where we build our solution and we test it with a small data set. We have the first step, which is evaluation and refinement. So we basically assess the solution with a larger data set, and we evaluate it against different metrics, such as groundedness, that we are going to see in a minute, coherence, which is basically how well the response flows smoothly and is grammatically correct, and relevance, so how relevant the answer is with respect to the question. And then finally, we have the 4th step, which is production. So deploying the application into production, and also monitoring, of course, the application. This is anything but a linear process. This is an iterative process. And during both stage 3 and 4, we might find that our solution needs to be improved. So we can revert back to experimentation, applying changes to the large language model, maybe fine-tuning the large language model, or choose another one, change the data set, augment the data set, for example, or the flow, and then evaluate the solution again. So in this session, we're going to explore the whole development life cycle, starting from step 1 to step 4. So from initialization to production. And, starting from the design of the solution based on large language models, we need to address, I would say, one of the biggest limits of large language models, which is groundedness. So language models are growing in popularity as they create impressive, coherent answers to a user questions. But as I mentioned, one prevalent challenge when implementing language models is really groundedness, which refers to whether a response is basically rooted, connected, or anchored in reality or to a specific context. In other words, groundedness refers to whether the response of a language model is based on factual information. And the main limitation of large language models is that they do not have access to data protected by firewall. They only have access to public data during their training, and their knowledge is frozen in a specific period of time, which is the time of training, of course. So you might have seen some, for example, jokes on internet with GPT-3 that wasn't, or GPT-3.5, which weren't, knowledgeable about the Queen's death, for example. And this is just because, the knowledge of large language models are really stale, frozen in time. For example, let's consider the two scenarios in this slide. We have an ungrounded scenario where the model generates an answer to a question about a product based on the data with which it was trained, which in the case of many large language models essentially means the whole internet. And the model uses the text it was trained with to generate a coherent, grammatically correct, and appropriate answer, but it's not based on a validated data source. So it might reference, for example, a real product that happened to be included into the training data, or it might even just invent a product, because the goal of the model is just to provide an answer to the question, even if the answer is not grounded on reality. While in the grounded scenario, so the scenario on the right side of this slide, a specific data source is used to provide context for the interaction. So the model bases its answer on the data in the provided data source. In this case, for example, might be a specific company's product catalog with all the list of the products and information about the products. And so the answer will be grounded in reality and based on the product information in the catalog data. So now, how to overcome this challenge? So how to incorporate domain knowledge to achieve the grounded scenario we had in the previous slide. To ensure that a Copilot, is grounded on specific data to provide accurate and domain-specific responses, we can use different techniques. And we have the free techniques we have here in this slide: prompt engineering, fine-tuning, or retrieval augmented generation. Now, in this session, we are going to focus on RAG, so retrieval augmented generation. But I wanted to, give you an overview of all the options we have here, and also what are the main differences among them. So first of all, prompt engineering is the design of the input to the model, configured so that the output is basically as close as possible to our expectations. In fact, we call prompt the input in natural language of a large language model, which can be as simple as, an incipit of a text to complete, but it may also contain many other information, such as instructions, a few examples, context, also the history of a conversation in the conversation domain, the style of the conversation. While when we refer to retrieval augmented generation, this might be seen as, a specific prompt engineering technique that allows the model to access private data, like enterprise data, by incorporating data directly into prompts, so into the model input. And it doesn't require to retrain the model. It doesn't modify the base model in any way. And the data are not persisted in the model. So you might need to, pass the same information several times if the model needs it in several turns of the conversation. On the other hand, we have fine-tuning, which means retraining the model on custom data by employing a technique called low-rank adaptation to integrate the new weights with the base model and creating a specific version of the model designed for a specific use case. So it requires additional compute to adjust the model's weights. If we want, to really find a difference, the main difference between fine-tuning and retrieval augmented generation, we could say that if RAG enables the model to learn new facts, fine-tuning basically is necessary to make the model learn new skills, like learning a new language, learning a new technical jargon, or to also modify the tone and format of the AI output, for example. In any case, all these three techniques I'm covering here are complementary technologies, not mutually exclusive. So there are cases in which you need to, use prompt engineering and retrieval augmented generation. There are cases in which you need to use all three techniques. So it really depends from one scenario to another. And Azure AI Studio is the technology we'll be using today for our demo, offers both RAG and fine-tuning to accommodate various application needs. And for those of you who are not familiar with Azure AI Studio yet, basically it's a hub which you can find at ai.azure.com, which basically unify all the data and AI technologies available on Azure. But we will see this later with Prime in a demo. Now, for the sake of this session, as I mentioned, we are going to focus on RAG, since it is efficient and cost-effective at adding knowledge to AI experiences to ground responses. And we previously said that RAG, in simple terms, might be seen as a prompt engineering technique in which we incorporate context data as input of a language model. However, the term RAG refers to the whole architectural design for hosting custom data, retrieving relevant data, and then including it into a large language model prompt. So looking at the RAG pattern represented in this slide here, it works like this. So first of all, the user inputs an initial prompt, which is used to search a data source and retrieve relevant grounding data. Then the grounding data is used to augment the prompt by adding additional contextualization and scoping text. And finally, the augmented prompt is submitted to the large language model, which can then generate an appropriate response in natural language. Again, you can use Azure AI Studio to build a custom Copilot that uses your own data to ground prompts. And Azure AI Studio supports a range of data connections that you can use to add data to a project, including, for example, Azure Blob Storage, Azure Data Lake, or on-premises file. Now, a RAG technique, a RAG architecture is as efficient as the data retrieval process embedded into it. Indexing your data source can help optimize the RAG process. And what is a search index? So a search index describes how your content is organized to make it searchable. So imagine, for example, a library containing many books, and you want to be able to search through the library and retrieve the relevant book easily and efficiently. So to make the library searchable, you create a catalog that contains any relevant data about books to make any book easy to find. So a library's catalog serves indeed as the search index. The user input is, in this architecture, the user input is used to query the index, enabling faster retrieval of relevant data with which to augment the prompt. And then, of course, how you configure your search index depends on the data you have and the context you want your language model to use. But as its simplest, an index enables you to look up data based on keywords in the user input. And this is what we call keyword search. Keyword search basically enables you to retrieve information that exactly matches the search query. Other search techniques, such as which are more advanced, such as semantic search, takes it one step further by retrieving information that matches the meaning of the query instead of the exact keyword, using semantic models. So currently, the most advanced technique is vector search, though, which creates encoding to represent your data in a numeric format. So as it's easy to understand, machines and AI models work better with numbers rather than plain text. And by using vectors, because the content is converted into a numerical encoding, you get basically a common basis that the search engine can use to match the user query with the data you have, with no requirement for matching on exact terms, language, or format, because you are using a numerical encoding for both the data source and the user query. Now, not all vectors are created the same. They can vary in their creation and quality. But one example is embeddings, which is a specific type of vector representation created by machine learning model. Like you might have heard already the OpenAI ADA embedding, which captures the semantic meaning of the text, representing words in the vector space in a way words with similar meanings are closer together in a multidimensional space. For example, here you have represented the word children and kids, closer one to another, or joyfully and happily, again, closer in the space to one another. And here, of course, we are using a bidimensional or three-dimensional space, but because it's the easier way to represent this. But of course, you should imagine that as multidimensional space, not just 2 or 3 dimensions. And in the Azure ecosystem, the tool which helps us leverage this vector search is called Azure AI Search Service, which was formerly called Azure Cognitive Search. So some of you might be familiar with the old name, the old naming. And this tool supports vectorization. And one of the key advantages of Azure AI Search is that it combines together the strength of different search approaches, like vector search and keyword search that we have just defined. In fact, vector search excels at understanding user's intent or relationship between words, but it struggles with things like exact matches. For example, if you're looking for names, for email addresses, or phone numbers, vector search might not be the best choice. Keyword search might be better, might perform better. So with Azure AI Search, you can choose to use keyword search only, you can choose to use vector search only, or you can use a combination of the two approaches, which is known as hybrid search. So combining the best of the two worlds. In short terms, when we use a hybrid search approach through Azure AI Search, the system is executing a hybrid query against a search index that contains both searchable plain text content and generated embeddings. And the merged results are then ranked using a semantic ranker, which prioritizes a subset of the matching result out of the previous step by taking into account also the context. Now, I think I have, I've done enough talking for now. So I really want to give the floor to you, Graham, for a hands-on demo of some of the concepts we just explored.
I'll be as handsome as I can. All right, let's switch to my screen if we can do that. That would be great. Oh, we're trapped in a mirror world. Let me switch over here. Okay, so hopefully you are looking at my Azure AI Studio environment. I'm here in Azure AI Studio. It's currently in preview. Pretty soon it will be becoming generally available. But this is our environment for working with not just Azure OpenAI models, but all sorts of large language models. And we can do, as Carlotta said earlier on, we can do things like fine tuning. We can practice prompt engineering. We can build prompt flows. But what we're really going to focus on today is implementing that RAG pattern. And to do that, I've already created ahead of time, I've created a thing called an AI hub, which is effectively just the resources in Azure that I need to do this stuff. And I've created a project that I can work on. So I've got this RAG Copilot project. I'm going to start off in this one here, this Copilot demo. So this is a brand new project, nothing in it already at this point. And I'm ready to get started. So the first thing I'm going to have to think about is I need some models in order to do some of the work. So I'm going to look at my deployments, and I will deploy a couple of language models that I'm going to use to build this solution. Now, the first one, you deploy these things as a real-time endpoint. So the first thing I'm going to deploy is a GPT model, and I'm just going to use GPT-3.5 Turbo. I could use GPT-4, I could use a whole bunch of different ones, but I'm going to use the GPT 3.5 turbo model, just because I've tested that and I know that that's going to work for me. So I can go ahead and give that a particular name so that I can recognize it within my environment. I'll just leave it with its default GPT-3.5 turbo name. And I can go to an Azure OpenAI instance. So I've got an Azure OpenAI instance already in my environment in that hub. I'm also going to make another couple of changes here. I could apply a content filter, which is a way of mitigating against harmful content. I'm going to leave that as it is. But what I am going to do is drop down this token per minute rate. This is really kind of guarding the amount of tokens, the amount of text that the model can deal with at any one time. And it starts with a default that's actually quite a high value. The reason I'm dropping it down is that quota is shared across the entire tenant, right? So every subscription in that tenant is drawing from the same regional quotas. And I don't need any more than 5K for this demo, so I'm going to drop it down. So that's always a good practice. Just drop it down to to what you need so that you're a good citizen within your environment. And we'll go ahead and we'll deploy that model. So it's going to go and create that deployment and deploy my GPT-3.5 model into my project. It should just take a couple of seconds to do that. And while that's doing that, let's just take a look at another project. I've got well, actually, let's look at the data we're going to work with. Is probably a good idea. So that's the GPT-3.5 model deployed. Actually, what I'll do is I'll kick off the next deployment, and then we can look at the data. So we're not only going to need that GPT-3.5 model, we're going to need another model because we're going to have to vectorize our data. And to do that, I'm going to create some embeddings. We mentioned those earlier on, so I'm going to use this text embedding model. So we'll go ahead and deploy that as well. So two different models, one specifically to do the embeddings that I need to create the vectors for my data when I'm indexing it, and one that I'm going to use as a language model to query that data to actually get me some responses. Again, I don't need more than 5K, so I'm just going to drop that down. 6 is close enough. Let's do that. So that's off deploying that model. I said I would look at the data. Let's take a look at the data that we've got. I've got a bunch of brochures here for a fictional travel company. And you can see that I've got, if I open up the Las Vegas brochure, for example, basically it's just a combination of some text and images and information about hotels in each of these cities that I have these environments for, these brochures for. Now, I could actually right now go ahead to my playground here. And since I've deployed a model here, I'm in chat mode and I've got my GPT-3.5 Turbo, I could actually ask it some questions right now. I could say, where can I stay in Las Vegas? And ask that question. But because currently this model is ungrounded, I don't get any information about my hotels, the Margie's travel hotels, as it were, in my brochure. It just literally goes and based on what it was trained with, and it was trained with information from all across the internet, it identifies some genuine hotels that are in Las Vegas. So it's giving me an answer, but the answer isn't grounded in anything. And for all I know, it could just be making up hotels in Las Vegas. So I really need to try and ground this model so that it's using data that I know is accurate, that I know is relevant, and that is contextualized for what I want to do with this model. Maybe I want to deploy this as a chat assistant in my Margie's travel website so that when you search the website, it tells you about the hotels that we can actually arrange for you. So to do that, I'm going to have to upload my data into this environment. And there's a couple of ways that I can ingest data into here. On this data tab, I can say I want new data. And I could create a connection to a data source. So in a real world scenario, your data might be somewhere like in Azure Blob Storage, or maybe it's in Azure Data Lake, or maybe Microsoft OneLake. Maybe you've used Microsoft Fabric to prepare the data. Perhaps you've already done some kind of filtering and preparation of that data in OneLake. And you could then specify, here's the location where that data is. Here's how I'm going to authenticate, and I'm going to bring that data in to this environment here so that I can use it in my Copilot. What I'm actually going to do is just much simpler than that. We're just going to upload some data. So I'm going to go and upload the data that we've already got there, and I'm going to upload a folder of data, and it's that brochures folder. So it's in my downloads, brochures, there it is. So we'll upload that. So it goes and finds those files, and then I'll just upload that, and I'll give that a name. We'll call it brochures, just because that's what it is. And so that data gets added to my project, right? Now, if in this case, just uploaded a folder full of files, but I could be pulling that data in from various sources, as we saw. So I've got the data. Now what I want to do is index that data. I want to create an index that makes it easy to search through that data. And I would do that by going to my Indexes tab and creating a new index. And in this case, I'm going to use existing project data, which is my brochures. And I'm going to use Azure AI Search to do my indexing. We mentioned that earlier on. So I have to already have an Azure AI Search service. And as it happens, I've got one. I've got one connected to my hub, my AI hub. So I've got my Azure AI Search environment there. I'm going to add vector search to that search. So I'm going to vectorize the data. And in order to vectorize it, I need that model that I created earlier on. So I've got my embedding model that I'm going to use my Azure AI service to apply. It's going to use this text embedding Ada 2. If I hadn't already deployed that model, it would deploy it. So I didn't really have to do that, but I've already deployed that model. So it's going to go ahead and use that model. And then I can give the index a name. It's going to require a virtual machine to go and do that index. I might call it something like brochures index or something like that. It's going to use a virtual machine to actually do the indexing, and that's going to take a little bit of time to do that. Now, to save us a bit of time, I've already done that. So I've been through these steps already in another project over here. So we can go to my indexes page here, and you can see there's my brochures index. So I've already done those steps. I've indexed that same data. So now I can go to my playground. And instead of just asking a question about, generally about staying in Las Vegas and getting a generic answer from whatever data it was trained with, I can actually specify I want to use my index in order to answer this question. And the way that I'm going to search is I've got that choice that we mentioned earlier on, all these different ways that I can search. I'm going to use a hybrid. I'm going to use both vector and keyword as I search. So it's going to vectorize my prompt. And it's going to, first of all, extract keywords from that and then use vector search based on those keywords. So I'll ask exactly the same question. Where can I stay in Las Vegas? And I will go ahead and run that. And off it goes and gets an answer. And this time, it tells me, here's the hotels offered by Margie's Travel. I've got the Volcano Hotel, the Fountain Hotel, and the Canal Hotel. If you've ever spent any time in Las Vegas, you probably know exactly what these hotels are. And it even gives me a reference to tell me it got this from the Las Vegas brochure in my data set. So now my prompt is grounded using the data that I've indexed and added to my system. So I'll hand back to Carlotta, so we can talk a little bit about something else and another way that I might use this index building a Copilot. But for now, that just shows you how easy it is to add some data, create an index, and then use that index data to ground your prompt when you're working with your large language model.
All right. Perfect. Thanks, Graham. So we have a few questions from the chat we might want to address before going further. We really have lots of questions. I would choose a couple, and then maybe if we have time later, we're going to address a few more. So, for example, let me see here. Mikin Makwan, he's asking, the user input in this context is also a prompt, meaning the second prompt is a grounded version of the initial prompt. So thanks for the question, Mikin. And yeah, that's right. So basically, we call the context, which includes data, but it might include also, for example, instructions about the tone and the style of the response, or a definition of a persona for the copilots. So all these kind of information are included in a part of the prompt, which we call system prompt or model prompt. And then the user query is the user prompt. So the two prompts are combined together, and then used as input of the large language model.
And it's worth saying we're actually going to look in just after we move on to the next session, we're going to look at something called prompt flow, which sort of brings together how do I assemble that prompt from the various pieces. I've got the system message that tells the model how to behave. I've got the user input, which I'm then going to use to look up data in the index. I might also have the existing conversation history, right? If I'm asking, it's the third question I've asked, I might want to ask that in context. So part of the prompt might be the questions and answers that have already been asked and answered in this session. So there's that prompt is kind of assembled using all these different components and then sent to the model to get the most relevant answer we can.
Perfect. Yeah, thanks. And then the next question from Jaco, sorry if I'm mispronouncing your name or nickname. So just curious, can I assume that caching mechanism is not needed in this workflow as user inputs are varying? So I would say that no. I mean, of course, the how much your input vary from one to another. It depends from your scenario, right? It depends from the users you have. But I don't. I mean, I think it's always a good idea to implement a caching system. And to be honest, Azure AI Search has also some, handles a caching system within the tool. So there's the possibility to enrich the pipeline with a caching system. So I would say, again, it depends from your scenario, but I would deep dive into enabling caching on Azure AI Search if you are interested in it, because it definitely makes sense, to add a caching mechanism. Graham, do you have anything to add here?
No, I think you nailed that one. Yeah.
Awesome. And then I will take another one before going further. So Damien is asking, in a RAG architecture, is the user's input always sent to a search engine before getting an answer from the LLM? Is it possible to only query the search engine when there's enough information? Do you want to take this one, Graham?
Use such a search engine before getting an answer. Is it possible to only query the search engine when there's enough information? Yeah, I mean, it's effectively just an index. If it's the caveat here is if it's a vector index, you're obviously retrieving vectors from the index, right? So you might not, you'd have to deal with that in your search. If you were just using a keyword index that just has text in it, yes, it's just a regular Azure AI Search index. So you could treat it as a source for search. You wouldn't then get the large language model generation aspect of things, but you could just search the index. Yeah.
Awesome. Perfect. Great. So I know that there are a few other questions. We will try to address them later, because we have some more content for you for today. So as Graham mentioned, in the next demo, we are going to see another tool, which is always part of the Azure AI platform, and which is called Prompt Flow. So I just want to, to give you an introduction about the tool, and then we will see this in action. So Prompt Flow is basically a development framework for defining flows that orchestrate interactions with an LLM. Prompt Flows is available as a feature of Azure AI Studio, where you can build your flow as a visual diagram, as you'll see in the demo, but also as a Visual Studio Code extension for those of you who prefer a code-first experience. And when I talk about flow, so a flow basically is composed by different building blocks. So it generally begins with one or more inputs, usually a question or prompt entered by a user. And in the case of an iterative conversation, the chat history to this point. And the flow is then, defined as a series of connected tools, each of which performs a specific operation on the inputs and other environment variables. And there are multiple types of tools that you can include in a prompt flow to perform tasks, such as, for example, executing a custom Python code, or looking up data values in an index, creating prompt variants, so creating multiple versions of a prompt for an LLM, varying system messages, or prompt wording to enable you to then, compare and evaluate the results from each variant. And then another tool, for example, makes you submit a prompt to an LLM to generate results, which is called LLM tool. And finally, of course, this flow has one or more outputs, typically to return the generated results from an LLM, or maybe sometimes several LLMs, if you include several LLMs in your flow. And the key to using the RAG pattern in a prompt flow is to use a tool which is called index lookup to retrieve data from an index so that subsequent tools in the flow can then use the results to augment the prompt used to generate the output from an LLM. And the index lookup tool has several parameters available. For example, we have the ML index content, which is the name of the index we are going to use, so the connection to the index we want to use. We have the queries parameters, which is basically the text to be queried. We have the query type, which is the type of query to be performed. We have seen that there are several types of search options available, including keyword, semantic, hybrid, and so on and so forth. And then we have the top K parameter, which is the count of top scored entities to return. Now, prompt flow provides, various samples you can use as starting point to create an application. So you don't need to start from scratch. You can clone also a template if you think one of the available template might be similar to the application you're trying to build. And once you build your own flow, you need to perform an evaluation on the flow, coming back to the development life cycle we have seen at the beginning. After the design of the solution, the testing of the solution, we also have the evaluation of the solution against the test data set to define basically if it's ready to be deployed or if there are any issues to fix before going to production. And briefly talking about evaluation, Azure AI Studio and prompt flow makes it easy to use built-in evaluation pipelines or create custom ones. And the main advantage of using those tools is that they leverage an AI assistant kind of evaluation. So basically a GPT-4 instructed model with an ad hoc prompt to score the generative AI application outputs. And the advantage here is that of course you can do a manual evaluation, right? So you can test against a data set your flow, and you can then have a team of human agents going through question and answers and see how well the model responded to the questions. But if you want to really scale the evaluation process, you need to automatize this process. And here's where the AI assisted evaluation comes into it's very handy. And also because, as I mentioned beforehand, with large language models, we don't really have ground truth. So we don't really have a set of predefined answers for our test data set. The answers can vary. And so, we cannot kind of evaluate compute and accuracy by just computing the difference between the ground truth and the predicted response. Now, the way this process works into the Azure AI platform is we need a JSON-L data set. So a data set in the format of a JSON-L file. And then we can create basically a batch run in Azure AI Studio to run the prompt flow against this batch test data set with our generative AI application. And then we create an evaluation prompt flow where we tell GPT-4 how and what to score. So under the hoods, we basically provide instructions to GPT-4 as how to go and look at our generated answers and measure to what extent is grounded, is coherent, is relevant, and so on and so forth. And then we feed the result of the batch run to the evaluation flow to get the resulting scores. So once we are satisfied with the results of the evaluation process, we are happy with our prompt flow, we can then deploy it to an endpoint. And once this is deployed on an endpoint, we can then consume this endpoint from client applications to implement Copilot functionality in our apps. So again, I will leave the floor to you, Graham, for the second part of this demo.
Okay, fantastic. Let's switch to my machine. If we can do that, get to my screen, great. All right, so let's take a look at some of these elements of prompt flow that Carlotta just talked about. So we've to remind you, we got to the point where we've uploaded our data, we've indexed it, and we've proven in the playground that I can use that index when I'm prompting, and I can get contextualized results back from that grounded prompt. To help me orchestrate that whole flow, I'm gonna create a prompt flow. So what I actually did here was I just hit create. There's a bunch of templates, and actually there's a whole gallery down here. And the one that I chose was this multi-round Q&A on your data. In other words, it's a standard prompt flow for asking a question, using your data to look up to ground the prompt effectively, like we've been doing, and then take the output of that question and add that to the chat history, so that we get the chat history, multiple rounds of conversation, adding more chat history with each round. So that's a template that does that. And what I've done is actually gone and created a prompt flow based on that template. So it looks like this. And I haven't really altered the prompt flow. I haven't added any tools or anything. This is what came out of the template effectively. I've configured it a little bit, but this is what's here. So I've got my inputs, which is basically, it's just, the definition is over here. It's basically just going to be the chat history once I've initially, asked a few questions, and then whatever the latest prompt is, whatever the prompt is that the user has entered, will get entered into that as an input. I then hit this tool, modify query with history, and basically what I'm doing there, let's find that tool. Basically, I'm using my Azure OpenAI GPT-3.5 turbo model that I deployed earlier on, and I am going to go and get the items that are in the chat history. Remember, that was one of my inputs, and I'm basically just adding them adding them to the question that was just asked. So I'm combining the latest prompt that came in from the user with the previous history of the chat. Then I've got my lookup. This is that index lookup tool that we talked about earlier on. And you can see those parameters we talked about on the slide, the ML index content, the queries, and so on. And what I'm doing is I'm using my index that I created earlier on. So this is that brochures index that I created on. That's the URL for it. I didn't mean to click that, but never mind. Because I registered that index in this project, it was easy for me to go and select that. So I've got that index selected. What I'm passing into that as a query is basically just the modified query with the history. So what came from that previous step. Here's what I've just had entered, and here's the contextual history of the chat. That gets passed in. I'm doing a hybrid search using vector and keyword, and I'm going to return the top 2 responses from that and use that to ground my prompt. Next step after that is I'm going to generate the prompt context. So I'm going to take all this information that I've got from my chat history and from the prompt that was entered and from the results of my lookup, and I'm going to generate the entire prompt context. And again, you can see there's some Python code here that does that. It gets the documents that were found in the search, and it's basically just going to start getting some information about those documents and add them to the prompt context. And then the next step is the prompt variants. We're actually just generating one variant. What I would do if I were really doing this in a production development environment, I would be creating multiple prompt variants, and I'd be varying things like the system settings. So you can see here there's a system message. You're an AI system designed to answer questions. I would create multiple variants of that, and that would allow me to evaluate when I come to evaluate my flow, which of those prompt variants works best. In other words, which system messages are giving me the most relevant responses when I do that. So that's why it's variants. It's because I might create multiple versions of the prompt. And then finally from there, I'm going to chat with context. And this is where I'm going to use my GPT-3.5 turbo model. I'm going to send it this prompt text, everything that I've assembled so far, that prompt variant that I've built. And what I'm going to get back from that is obviously some sort of output. So the output from that is basically just going to be the text that comes back. In this case, you can sort of see some data about it. This is because I've already run it, so you can see some responses here. But that's pretty much it. It's a fairly simple flow. It's fairly logical. It looks pretty complicated when you start to sort of dig into the code and so on. But most of this was generated for me. I just filled in a few of these settings to tell it which models to use and which index to use for the lookup and so on. And I can, right here in this test environment, I could go ahead and I could chat with that just to prove that it works. So you can see it's retained this. This was the previous thing that I asked it. Let's try it something else just to prove that it works. Let's look at what there is in San Francisco. And we'll go ahead and run that. So there's my prompt going in. You can actually see some movement over here as it works its way through these different tools. So it's going through that prompt flow. It's doing each of those different steps that it had in the prompt flow. So we're going to combine this with the chat history. In this case, it's the first message, so there isn't any. It's going to do a lookup in the index to find the relevant information for the keywords that it's found in that input that I just gave it. It's going to use all of that to assemble a prompt. It's going to then speak to the model. And what I then get back from the model is a grammatically correct response that is grounded in my data. It even tells me it's grounded in that San Francisco brochure. Now, I did see a question earlier on, somebody asking, can we see the grounded prompt? If I actually look at these tools as we go through, so this was me picking up the history and so on. What I should be able to find, I can get the scroll bars to work properly. Here's the lookup. And I should be able to see the output from the lookup. The output from the lookup is the data that it's found in various relevant documents. So the top two documents, the top two it found that mentioned San Francisco were the Margie's Travel Company info brochure and the San Francisco brochure. So I can see that it found those when it searched the index. It then generated the prompt context. And again, I can see the output. So here's what that final prompt looked like. And you can see that it's stuffed in the data that it got from the search. That becomes part of the prompt as well. And then it's generated the prompt variant. So here's the overall prompt. The system message, you're an AI system, blah, 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 blah. And then it tells it to respond with the citation and so on. Then it gives it some contextual data. So it gives it the information about that it extracted from the search index. And then finally, the question I entered, where can I stay in San Francisco? So that's the overall prompt that's been put together. That's then sent. And then I finally get my output at the end. And here's the output that we got. So I can trace the whole flow through. I can see everything that happened throughout that flow. In production, as we mentioned, the evaluation is important. So I would go to this evaluation tab and I would create a new evaluation. I'm not going to do that just for the sake of time, but as Carlotta mentioned, I could use some existing pre-canned, here's some questions I want to test my flow with, and then run those through as a batch and compare the outputs and fine-tune not fine-tune, that's the wrong term. Look at my prompt flow and choose the appropriate system messages and so on that I need to do to get the best results. And when I'm happy with that, I can then go and deploy my endpoint, deploy the flow to an endpoint rather. I've already done that here. So here I've got my brochure endpoint. And I've opened that up. This is just an HTTP endpoint. There's the URL for this endpoint. It's just effectively a model that's deployed as a web service. I could test it. So I could do something like, what can I do in New York? Let's try. And off it goes, and it's going to call that flow at the endpoint where I've deployed it, and I get back my responses. Now, remember that it retains the chat history, so I could ask it something like, where else could I go? And because it's retaining the chat history, it's in context. It knows that I've already asked about New York, so now I'm saying, well, where else other than New York could I go? So it's going to go and have a look up in the index and see if it can find anything relevant to answer that question. And hopefully, we should get a relevant response appearing in just a second. Certainly doing some lookup and parsing through the documents there. I can see it's having a think about it. Of course, it's the last step of a live demo, so there's always the risk that it's
Yeah.
gonna have to fail. But let's keep our fingers crossed and hope. There we go. Yeah, we specialize in other places, right? In addition to New York, so it's retained the history as part of the context, and that's gone into the prompt that was augmented. Final thing for you, as developers, obviously this is great. It's all nicely done in AI Studio. How do I build this into an application of my own? Well, we actually give you the endpoint information that you need, the keys and so on you need to connect to it. And in fact, we give you the code that you need to use in a JavaScript or Python or C# or even R client if you wanted to build a client application for that endpoint. So it's really fairly straightforward to use AI Studio to upload your, well, first of all, deploy your models, upload your data, create your index, create a prompt flow that allows you to orchestrate the way that your prompt is assembled, validate that, evaluate that, and get the best possible prompt for your data, and then deploy that as an endpoint and consume that in a client application. So hopefully that gives you the end-to-end story. Carlotta, back to you.
All right. Huge thanks, Graham. This was very insightful. We have a few other questions in the chat. Who I would like to address another couple of questions before going forward with what we have here. So, for example, Hack is asking about regions. So he's saying, if I'm working with the GPT-4 Turbo with vision model, do I need to have the hub, the project, and obviously my OpenAI resource in the same region where the model is available? Please talk about regions. So, yes, I mean, not all the models are available in every region. So you should check the documentation to see, for each model and for each model version where these are available. So you need to have your Azure OpenAI resource, of course, in the region of availability. Then I saw you are asking also, what about the web app, which is maybe consuming the generative AI, for example, the endpoint when you publish your flow on an endpoint and then you consume it on from another web app. Yeah, in this case, the web app can be hosted in a different region. So the model availability affect only the Azure OpenAI resource region, not the web app which is consuming the endpoint. So this hopefully helps you about regions stuffs. Graham, do you have any comments here?
Yeah, just to add to that, when you define your AI hub, you'll select a region, and that is by default where your Azure OpenAI service will be deployed. You can actually point it to another Azure OpenAI service in your subscription, which could potentially be in a different region. Your AI search service doesn't have to be in the same region. That could be in a different region. So you can spread these around. You're then going to have the data egress issue, right? You've got a performance and potentially a cost hit as you move data across those regional boundaries, because you're going to have to connect. If something's in Southeast Asia and something else is in North America, then there's connectivity there. So for best performance and for best cost management and so on, you would want everything in the same region. But as Carlotta said, some of the models aren't available in all regions. So you're going to have to choose a region where the model you want to use is available. And even more than that, within a given Azure tenant, there is a quota. You remember when I deployed the models, I reduced the token per minute that it was using. I reduced the amount of quota it was going to use. There is a finite quota in the tenant. So if there are multiple subscriptions or multiple deployments in the same tenant and they're in the same region, they'll all be pulling from that same quota. So what you might want to do is distribute, if you've got multiple AI hubs or multiple Azure OpenAI instances, you might want to distribute them across different regions in order to make sure that you're not all pulling from the same quota, and eventually you start to run out of available quota for using the service.
Perfect. Thanks, Graham. We have another question from Sam. In terms of cost, how much cost to replicate a demo like this on my account? Graham, do you have any insights about that?
I don't have an exact figure, and obviously it will depend what currency your Azure subscription is in. But I mean, this particular demo If you literally, like if you do the lab, if you go and do the lab that we have associated with the model, and you do it in one sort of sitting, so you do it and then dismantle it at the end, then you're talking a handful of dollars. It's not going to be a ridiculous amount. If you leave it running, here's the key thing: if you leave that prompt flow environment running, if you leave your endpoint deployed, yes, it will start to accrue, and over days you start to get into potentially hundreds of dollars, and if you leave it running longer, then a lot more. So just to do what I did today, if you do it within a sort of 30-minute to an hour kind of span, you're possibly talking a couple of dollars. Just remember not to leave it running.
Yeah, great tip. And I'm seeing Javier also asking about a demo lab to replicate this exercise. As Graham said, the exercise he just went through is included in the Learn module. So yeah, you can always replicate this demo on your own Azure subscription. You will have all the instructions step by step in the Learn module. So you have the link in the chat, but we are going also to share again the slide with the QR code. So make sure to stay till the end to have the possibility to scan the QR code again if you are interested. Awesome. So we are, I would say, at the end of the session. So just to wrap up what we have done, we truly went through the full development life cycle by defining our use cases, designing our Copilot solution with the prompt flow, and when setting our Azure AI Search index. We experimented with large language models, and then we also deployed the flow into production. We covered also a bit about the evaluation step. And if you go catch, previous episodes of this series, you will also get some more insight and information about evaluation in prompt flow. So we have addressed a few questions from you, and thanks for asking questions in the chat and being so active. Now we have some questions for you. So we'll be sharing a link to a poll that you can use to vote and answer to this knowledge check. So it's just a brief quiz to wrap up this session. So here's the link that you can use to vote for each and every question, aka.ms/polls-a. You also have the QR code here if you want to, just scan the QR code and jump directly to the page of the quiz. And this is our first question about groundedness, how we started this session basically. What does groundedness refer to in the context of generative AI? So we have three possible answers. We have A, the use of a locally deployed language model, B, using data to contextualize prompts and ensure relevant responses, or C, using the lowest possible number of tokens in a prompt. So go ahead and choose your the answer you think is most suitable for this question. Graham, any tip you have to how to approach a question like this?
Hopefully you were listening earlier when we talked about that. Think about being grounded. Think about the idea that we're what are we trying to achieve here by grounding the model?
Awesome. And I've seen that already a few people is providing the right answer. So let me reveal the right one. And congratulations to everyone who answered correctly. So the answer is B, as Graham just suggesting. So groundedness refers to using data to contextualize prompts and assure relevant responses. So we have talked about grounding the responses of our Copilot. So that's what we are talking about. And
it's not electricity related, as somebody is suggesting.
Yeah,
we're not grounding the server.
Great. So question 2, again, same link to vote, aka.ms/polls-a. So question 2 is about what pattern can you use to ground prompts. So we have defined what groundiness is. Now, how we ground, how we can ground our prompts. We have 3 options here. A, metadata optimized prompt. B, data understanding support text. And C, retrieval augmented generation. So go ahead and vote. What is your the answer to your question? And I'm seeing some answer coming in the chat. Thanks for sharing. This was an easy one, I guess. We have the acronym in the title, so this should be an easy one. I need to mop and dust at home. Okay. So let's reveal the correct answer, which is, of course, C. So congratulations to everyone who answered correctly. The pattern we have used to ground our Copilot response is called RAG, so which stands for Retrieval Augmented Generation. So let's go ahead with question 3. Same links, aka.ms/polls-a. Vote the answer you would like to give to this question, which is also the last question of the quiz. So which tool enables you to retrieve grounding data in a prompt flow? So this is specifically to prompt flow, and we have used this tool, Graham used this tool during the demo. So we have 3 options as always. We have query tool as option A, content safety tool as option B, and then as option C we have index lookup tool. So go ahead and provide your answer. So in the chat this time we have a few half people saying C, half people saying B. Let's see if some other answers are coming. We have an A also. Okay, so there's a bit of confusion here. Let's see if we can clarify that. So the answer is index lookup tool. So the correct answer is C. Congratulations to the ones who guessed the right answer. Let me just add a few words here. So the tool, then of course this is mostly the naming of a tool in the prompt flow, so it's totally fine to do not remember the name of all the nodes. It was probably the trickiest one, but the name for applying the RAG pattern into prompt flow, the name of the tool is called index lookup tool. The content safety tool is a tool that exists indeed. And it can also be applied, it should be applied to a generative AI application like Flow we have seen in this demo, in this session, because content safety tool basically applies a layer of moderation and filtering to the solution. We haven't really covered these in details during this session, but content, we know that large language models has some sort of limitations in the sense that they can generate harmful answers. So it's important to use tools like content safety tool to make sure that we can apply a layer of filtering and moderation and ensure that we are building our solution following the responsible AI practices and principles. And again, in this series, we also had a deep dive episode around responsible AI. So if you are interested, you can catch it up. But yeah, just wanted to clarify the content safety tool. It does exist. It's just, it has a different functionality. Cool. Anything to add, Graham, to this question or the knowledge check in general?
No, I think people did very well. I'm looking at the poll results, and by and large, people did pretty well on the thing. There were a couple of wrong answers, but pretty much in 95% got questions 2 and 3 correct. So well done. Obviously, you were staying awake throughout our presentation, which is all we can ask for, really. So thank you for that.
Yeah. Thank you. Huge thanks. Awesome. So I would say that we are at the end of our session today. So let's just recap what we have seen so far. We have talked about groundedness, so the benefits about grounding language model with the Retrieval Augmented Generation pattern. We have seen how to index your data with Azure AI Search to make it searchable. We have talked about what is vector search, what is a vector, how to create an index. And then we also have seen a hands-on demo about building a Copilot kind of solution using RAG and using Azure AI Studio and Prompt Flow tool. As we mentioned before, this session was based on a Microsoft Learn module. So I wanted to just reiterate that you can go through this content also at your own pace. By going through this Learn module, doing the exercise on your own. You will find the step-by-step instructions to replicate the demos you have seen today. So make sure you have this link at hand or scan the QR code because it might be helpful to deep dive into these topics at your own pace later on. And another important thing is this is not the last the last session of the series. The last session is tomorrow, and we are going to go over similar topics. I've seen that there were lots of questions also about the kind of search, so vector search versus semantic search, or how to set up indexes. There were some questions, so I hope that you can follow tomorrow's session to get some of your questions answered. This will be really a deep dive about Azure Search and about setting up an index for the RAG pattern. And you have here also the link to the session to register. Of course, it's always free, and the QR code to reserve your free spot to tomorrow's session. And then another thing I would like to say is that all these sessions are also recorded and available on demand after the live streaming. So you will find the recording of the session on YouTube, on Microsoft Reactor YouTube channel, and on Microsoft Learn. So don't worry if you cannot you missed a piece of the live streaming, or you missed some other episodes. You can always rewatch them. Very last thing, we have a wonderful AI community on Discord server that you might leverage, to just meet other AI enthusiasts and share your questions there as well. There's a very friendly community of Microsoft MVPs, Microsoft FT full-time employees, and just Microsoft developers. So you can share your questions, share your learnings there. Also useful resources. Sometimes you can find useful resources to continue your learning. So if you are just interested to join a friendly community to continue your learning journey, this is definitely a community you should join. And that's it for the session. Thank you so much, everyone, for joining us today, and thank you so much, Graham, for joining us.
Well, thank you, Carlotta. Great job.
Awesome. See you tomorrow then. Bye bye.
Bye, y'all.